We had already introduced wires. I think today we are just going to talk some more wires. And if you find me or in repair talking about conductors, basically that's wires. Basically they are metals. So I do not know what to tell you about the things except one or two things. Of course, we know that the functions of these is just to bridge points or components. Bridging is like connecting to allow movement from one place to another. So basically that's what the purpose of wires, conductors or metal are in electronic repairs. And I think it's just that much to know about wires. Today I thought I may just maybe mention a few little things to understand about wires. One is, you know, that its resistance is almost negligible. That means less than or equal to 0. And we know that resistance is measured in ohms. That earphone-like sign. So that is the resistance of wires. So in most cases, it's almost 0 resistance. And the other thing, maybe if you want to be much of a geek, is to understand that actually, much as it has close to 0 resistance, that resistance also does change. And it is affected by one or two things. I think you all remember what resistance was. So whenever there is an increase in temperature, we shall find that resistance of wires or conductors tends to also increase. Yeah. And for those who may want to understand the physics behind this, you remember when we talked of electricity, we said it's simply the flow of electrons. And that means anything that tries to stop this flow tends to increase the resistance of that conductor. And why does heat tend to increase the resistance of a conductor? That's one. We actually said much earlier on that when you look at a conductor, it's made up of atoms. If this conductor was, let us say, copper metal, then it is made up of atoms of copper metal. And since electrons are flowing through this conductor, that means if they are going to be opposed, that means their movement should be blocked. And I think you guys know that when you hit something, its kinetic energy increases. Do you know that? Yeah, so basically when you apply heat to this conductor, the atoms of copper that are inside this conductor, okay, copper, aluminium or tin, whatever, the atoms will start vibrating, like they will have kinetic energy. So as they vibrate, they tend to block electrons. It's like if you wanted to pass through a door and there is someone who is moving left to right on the door, it becomes harder for you to enter the door because chances of you not bumping him are high. But if they were stationary on one side of the door, you'd know that I should pass on the other side. But if the guy starts oscillating or vibrating around the entrance, moving from left to right, when you think he's on the left and you go right, he's on the right, so you end up hitting him. So you find that it will be hard for you to move. That's actually the reason why rise in temperature, or if the heat of the wire increases, its resistance increases. Of course, not so much like you would see the values become big, like the way you would see in resistors or semiconductors or insulators. But if it was like, let's say 0.1 ohm, perhaps its resistance would increase to 0.3 ohms. It's still low, it's still below 0, but it's something. And normally that tends to help us with circumstances such as when you look at fuse wires. Actually, when you look at a fuse, it's also just a conductor. a conductor joining one point to another, only that this conductor has an amount of current beyond which it will heat up, and once it heats up, that heat causes its resistance to go up, and when that resistance goes up, more heat is generated, but it goes up to a point that it melts that wire and breaks it. That means that the temperature has reached a point that is almost close to the melting point, or at the melting point, or higher than the melting point of that wire, because of the heat that has been generated internally in the wire because of flow of electricity. And I wanted to just tell you that actually heat is generated whenever current flows. In other words, current always creates work, and that work in most cases can be IV times the time in which the current has flown. But this is for another day. This could give you the work or the heat that is generated into that wire. Anyway, that's it for today about wires. I think tomorrow we shall talk some more about wires, and I do not know whether Nathan has any questions. Do you think you have any question today?
No.
Sure.
No.
Okay, me, I have questions for you. Okay. So help me explain why the resistance of the wire increases when its temperature increases.
I think the resistance of a wire increases when the temperature increases. It's when the particles or the atoms in the copper start vibrating, causing that it's like they are preventing the resistance. They cause resistance when they vibrate.
How do they cause resistance?
They cause resistance because they are moving back and forth, like they are moving vigorously, causing that they are blocking the electrons that are coming in.
Yes, that's true. So increase in temperature of the wire or a metal increases resistance because it increases the vibration of the atoms. So as they are moving about, they block electrons that would want to pass or flow through the other end, so they end up, only few end up going through. And we know that resistance is the opposition to the flow of electricity, and we know electricity flow is basically a movement of electrons. So when something makes it hard for electrons to flow, it causes the resistance of that something to go high. Anyway, I thought that's an examinable question, so I decided to just throw it there. So that's what we've learned today about wires. To know that metal conductors, they just bridge 2 points to allow electrons move from one point to the other, and also the fact that when its temperature rises, it tends to cause the resistance of the wire to increase. Much as the resistance still is a little low, but there are under scenarios under which it becomes significant. It is worth mentioning. Now when you come to digital electronics, where we're dealing with very minute currents, even a slight increase in resistance could be problematic to that component. But that's not part of today's work, but I just felt you should know that. It's one of those things that be in the background of your head when you're doing repairs and could explain a scenario that you are going through. Anyway, hit the subscribe button. Feel free to always come back, and see you in the next video. Oh, like the video, better share, recommend a colleague. I mean, that's if at all I'm making any sense anyways, because I would want to edify you. All right, see you in the next video.
Thank you.